Very good morning to all of you. Today I want to start Module 3, Session 1, and title of Module 3 is Stability of Slopes. This Module 3 is divided into two parts. First part is Stability of Slopes. Second part is Lateral Earth Pressures. Now I want to finish first part 1, that is Stability of Slopes. Title of that is a course outcome of Module 3 is given ability to estimate factor of safety against failure of slopes and compute lateral pressure distribution behind earth retaining structures. So this is the course outcome of this slope stability of slopes and lateral earth pressures. Okay, I will once again read out course outcome: ability to estimate factor of safety against failure of slopes and to compute lateral pressure distribution behind earth retaining structures. Title of subject is Applied Geotechnical Engineering and subject code is 18CV62. This comes in 6 semesters of civil engineering departments. So this is the introduction of first slides. Next slide, contents. So to cover the session 1, these are the contents are prepared. To finish in details, that is stability of earth slopes, types of slopes, causes of failure of slopes, types of failure of slopes, definition of factor of safety. These contents are required to explain in details to finish session 1 of today's class. Now let us see. Generally, slope structures are constructed by civil engineer for the stability purpose. So that's why nowadays so many structures are responsible to retain as usual in original design and shape of structures throughout their life. So here see types of slopes, how slopes are classified. There are basically two types of slopes. One is natural slopes, second one is man-made slopes. So these are the two types of slopes are there. Let us see natural slopes. The natural slopes are those that exist in nature and are formed by natural causes. The natural slopes are those that exist in nature and are formed by natural causes, such as slopes exist in hilly areas. Natural slopes are exist in hilly areas. This is the examples of natural slopes. Second type of slope is man-made slopes. Man-made slopes. The side of the sides of cuttings, the slope of embankments constructed for taking roads, railways lines, canals, etc., and the slope of earth dams constructed for storing water are examples of man-made slopes. Okay, you remember this is the most important concept of man-made slopes. The sides of cuttings, the slope of embankments constructed for taking roads, railway lines, canals, etc., and the slope of earth dams constructed for storing water are examples of man-made slopes. These are the two types of slopes are explained with examples. The slopes, whether natural or artificial, may be infinite slopes, and second one is finite slopes. The slopes, whether natural or artificial, may be classified as infinite slopes and finite slopes. Next, let us see what we mean by infinite slopes. The term infinite slope is used to designate a constant slope of infinite extents, endless. The long slope of the face of a mountain is an example of this type. The long slope of the face of a mountain is an example of this type. What do you mean by finite slopes? Finite slopes are limited in extent. Finite slopes are limited in extents. The slopes of embankment, earth dams are examples of finite slopes. The slopes of embankment, earth dams are examples of finite slopes. The slope length depends on the height of the dam or embankment. The length of the slope depends on the height of the dam or embankments. Now let us see what are the causes of failure of slopes. So this slide is explains for causes of failure of slopes. The following are the causes of failure of slopes. So these are the failures. Slopes or failure takes place due to these parameters. One is gravitational force. Due to gravitational force, slopes or failure takes place. Second one is force due to seepage of waters. Force due to seepage water. So due to this is also slopes or failure takes place. Next is erosion of surface of slopes due to flowing of waters. Erosion of the surface of slopes due to flowing of waters. So this due to this is also slopes or failure takes place. Nowadays, best example is towards northern sides. Okay, Kedarnath is best example for third erosions. Okay. Next is the sudden lowering of water adjacent to a slope. Next causes is the sudden lowering of water adjacent to a slope. Due to water table is lower, adjacent slopes is failure takes place. Forces due to earthquakes. So due to earthquake also slopes or failure takes place. Okay. So these are the some diagrams are given based on above causes of failure slope. See here this first diagram This is the infinite slope. Okay, so this is firm strata, this is component of weight, this these dotted lines are failure takes place, failure surface, slopes are decreased downwards, so that is failure takes place. See second figure, this is earthen dam sketch. Okay, this is ground level, this is A point, this is B point, this is C point, and this is the failure surface. This is the failure surface. This is component of weight of earth dams. Okay, so this is the failure surface in earth dams. See figure C. Seepage below a natural slope. Seepage below a natural slope. So this is the natural slopes, and this is seepage parallel to slopes. So this is seepage that takes place. So due to this natural seepage of water, slopes or failure takes place. See these diagrams. So this is the embankments. So this is the embankments, and this is groundwater tables. This is water tables. So from here to here, due to lowering of water level, failure surface is occurred like that. Okay, from here to here, water table is lowering, so then this failure surface area takes place. Next, due to earthquake, how slopes or failure takes place. See, this is the embankments or earthen dam embankment structure. Due to earthquake, this type earthquake, this is earthquake force, this is weight of the earth, so like that failure slopes or takes place. So these are the examples of forces that act on earth slopes. So these are the clear explanations are given with sketches also. The effect of all forces listed is to cause movement of soil from high point to low points. The most important of such forces is the component of gravity that acts in the direction of probable motion. The various effect of flowing or seepage water is generally recognized is very important in stability problems. Seepage waters, but often these effects have not been properly identified. It is a fact that the seepage occurring within a section mass causes seepage forces which have much greater effect than is commonly realized. Erosion on the surface of a slope may be causes of the removal of a certain weight of soil and may thus lead to an increased stability as far as mass movement is concerned. So due to erosion of soils. On the other hand, erosion in the form of undercutting at the toe may increase the height of slope or decrease the length of incipient failure surface, thus decreasing the stability. When there is a lowering of the groundwater, or of a free water surface adjacent to the slope, when there is a lowering of the groundwater or of a free water surface adjacent to the slope, for example, in a sudden drawdown of the water surface in a reservoir, there is a decrease in the buoyancy of the soil, which is in effect and increasing in the weight. This increase in weight causes increase in shearing stresses that may or may not be in part counteracted by increase in shearing strength, depending upon whether or not the soil is able to undergo compression, which the load increase tends to cause. If a large mass of soil is saturated, if a large mass of soil is saturated and is of low permeability, practically no volume changes will be able to occur except at a slow rate. And in spite of increase of load, the strength increase may be appreciable. Shear at constant volume may be accompanied by a decrease in the intergranular pressure and an increase in the neutral pressure. A failure may be caused by such a condition in which the flows like a liquid. A condition of this type may be developed if the mass of soil is subject to vibration, for example, due to earthquake forces. Soils or failure takes place. The various forces that act on slopes are illustrated above figure 3.1 in details. Now, types of failure of slopes. How failure slopes are classified. The types of failure that normally occur may be classified as slope failure, toe failure, base failure. These three types of slopes of failure identified. One is slope failure, toe failure, base failures. Okay, see these diagrams. So this is the embankment, that is earthen dam. This is ground level, this is top width of dam, this is upstream, this is downstream side. These are the rotational slides. Okay, this is circular rupture surface. Okay, this is called rotational slides. Slope failure takes place. So this is the rotational slides. This figure is slope failure. So towards the slope is failure from top width towards the slope. Like that, slope is failure. Soil of high strength, these portions. This is upstream, this side is downstream, this is top width. Okay, slope failure takes place like that. See, this is toe failure. This point has toe. This has toe. This is top width of dam. This is this side upstream, this side downstream. And this is homogeneous soils. Toe failure means from slope is failure from toe towards top width of dam. So this portion is failure takes place in terms of toe failures. See, this is the base failure. So this is the base points. So failure, slope is failure from the base towards the top width. So this is called base failure takes place. Let us see explanations about each slides, how failure slopes. Rotational slide means when soil slopes along a circular surface, such as a slide may be termed as a rotational slide. It moves downward and outward movement of a slice of earth as shown in figure 2a. See, this is the rotational failures. Okay, it involves downward and outward movement of a slice of earth as shown in figure 2a, and sliding occurs along the entire surface of contact between the slice and its base. This is called rotational slides. Slope failure. In slope failure, they are of the rupture surface meets the slope above the toe. This can happen when the slope angle beta is quite high and the soil close to the toe possesses high strength. So this is slope failure. Toe failure. The failure occurs when the soil mass of the dam above the base, below the base is homogeneous. It's called a toe failure concept. Base failure. The failure occurs particularly when the base angle beta is low and the soil below the base of the dam is failure takes place. Base failure is fails from the base towards the softer sides to top width of the dams. So this is the base failure concept. Definition of factor of safety. So what do you mean by factor of safety? So in terms of stability slopes, how factor of safety is defined. In stability analysis, two types of factor of safety are normally used. In stability analysis, two types of factor of safety are normally used. They are factor of safety with respect to shearing strength. Second, factor of safety with respect to cohesion. So factor of safety are referred with respect to two parameters. One is with respect to shearing strength, second is with respect to cohesions, that is tau and c. This is also termed sometimes as factor of safety with respect to height. Which one? C is also sometimes referred as with respect to height. Let Fs is the factor of safety with respect to strength. Fc is factor of safety with respect to cohesion. Fh factor of safety with respect to height. Fi factor of safety with respect to friction. Cm dash is nothing but a mobilized cohesions in kilonewton per meter square. Phi m dash means mobilized angle of internal frictions in degree. Tau is average value of mobilized shearing strength in kilonewton per meter square. S is maximum shearing strength, that is also expressed in kilonewton per meter square. Then factor of safety with respect to shearing strength may be written as Fs equal to S by T. So here S means C plus sigma tan phi. So based on the Moore-Coulomb concepts. Okay, C plus sigma tan phi means C dash plus sigma dash tan phi dash by tau. This is equation 1. The shearing strength mobilized at each point on a failure surface may be written as tau equal to C plus sigma tan phi by Fs, or C dash plus sigma dash tan phi dash by Fs, or tau equal to Cm dash plus sigma dash tan phi m dash. This is equation number 2, where Cm dash is equal to C dash by Fs and tan phi m dash equal to tan phi dash by Fs. This is equation number 3. You remember these equations. These are the most important equations while solving the problems. Okay, these equations we are using. If the factor of safety with respect to cohesion and friction are different, we may write the equation of the mobilized shearing resistance as tau equal to C dash by Fs plus sigma dash tan phi dash by Fi. So this is the equation number 4. So these are the final equations obtained to calculate factor of safety with respect to cohesion, with respect to shearing strength, etc. These are the references are referred for covering module 3 of session 1. Okay, thank you one and all. Next class I will be continue.